Hi all. Today we'll be discussing the LeetCode problem of the day, maximize happiness of selected children. So you're given an array happiness of length n and an integer k. There are n children who are standing in a queue, and happiness of the ith children is denoted by happiness of I. So now you have to select k children from these n in k turns. So in each turn, you have to select one child, and the happiness value of all the other children gets reduced by 1. So for example, if you pick this child, you'll get a happiness value of 2. But by doing this, the happiness value of all the children uh, gets incremented by 1. So the new happiness value of all these children will be 2, 0, 3, and 1. Also note that the happiness value of any child can never become negative. So once it reaches 0, then it won't get decrease further. You just have to return the maximum sum of happiness values of the k children you select. And you can choose in what order you can do it. So now let's look at the example. You have 3 children and k equal to 2. Okay. So first, if you pick this child, you'll get the happiness value of 3. And by doing this, the happiness of all the remaining children gets reduced by 1. So this is 0 and this will be 1. Next, you can pick this child. By doing that, you'll get a happiness value of 1. Since k equal to 2, you can only pick 2 children. So the maximum value you can achieve is 4. Now in the second example, you have 4 children and k equal to 2. So suppose you pick this child, you'll get the happiness value as 1. And by doing that, all the remaining children gets decremented by 1. Next, you need to pick another child. Okay, 0. So for another child, no matter what you pick, you always get a 0. So suppose you pick this, you get a 0. So total answer is 1. Output is 1. So finally, you have this example 2, 3, 4, 5. So here you have k equal to 1. So the only best way is to pick this child with the maximum with the happiness value 5. So you'll get the answer as 5. Suppose here k was 3. Then once you pick this 5, all this will get decremented. So this becomes 2, this becomes 3. Next, maybe if you pick this child, you'll get the happiness value as 3. This is 0 and this is 1. Next, if you pick this child, you'll get a happiness value of 1. But once you pick this child will not become -1. So once the happiness of any child reaches 0, then it remains 0. So for k equal to 3, your maximum value will be 9. Now coming to the constraints, the maximum length of the happiness can be up to 2 into 10 power 5. And the happiness of each child can be from 1 to 10 power 8. And of course, k will be from 1 to n. And due to these constraints, you can note that the return value will be in long. Now let's go over the approach. So every time you pick a child, the happiness of every other child gets reduced by 1. That means the longer you wait to pick a child, more of their happiness will be dropped. So due to this, children with higher happiness should be picked first so that they lose less happiness before they are picked. So first we have to pick the child with the greatest happiness, which is 4, then 3, then 2, and then 1. So let's see for this example what we get as the answer. So first we pick this child, we get the answer as 4. And then all these gets reduced by 1. So 0, 1, and 2. Next we pick this. So we get a happiness 2. And then this 0, so it won't reduce further. So it remains 0. And this one will become 0. Then this child has 0. And finally this child also has 0. So by picking in greedily in the descending order, we get the answer as 6. So here we can argue one thing, that uh, by the time we reach these two children, their happiness was already 0. What if we started picking from these children? Then we could have got some positive happiness from these children. So let's compare what happens when we pick the children from the ascending order. Before doing that, let's first write what happiness we got from each of the child. So from this child, we got the happiness. Let me write it in green. So we got the happiness as 4, and there were 0 deductions. Next, from this child, we got the happiness as 2 because there was one deduction, because before this we picked this child. Next, for this child, we were able to pick 0 because the deductions were 2. And finally, for the last child, we were able to pick 0 because the deductions was 1. So this was a total answer, 0 plus 0 plus 2 plus 4, which is 6, because we had total this many deductions. Now let's see what happens when we pick in the ascending order. So first we'll pick this child with happiness 1, and due to that all the other will get reduced by 1. So 1, 2 and 3. Next we pick this child, so his happiness is 1, and due to that the other ones get reduced by 1. So this is 1 now, and this is 2. Next you pick this child, and he has a happiness 1, and then the happiness of the remaining child gets reduced by 1. Finally you pick the last child, and his happiness is also 1. So total happiness you could collect was 4. So in this case, let's see what was the happiness of each person you could get and what was the deductions. So let's quickly compare them here. So this is for the case where we picked in the descending order. Now let's see what is the happiness if you picked in the ascending order. So first we have picked this child. So he got 1 happiness and deductions was 0. Let me write deductions in red. And next for the second child, you could pick 1 and the deductions was 1. Next child also, deductions was 1. Then for the next child also, you got the happiness as 1, and you got the happiness as 1 because there were 2 deductions. And finally, for the last child as well, you got the happiness as 1 just because there were 3 deductions. Yeah, so due to this, your maximum happiness you can get is 4. Write it in green. Maximum happiness was 4, and in the descending case you got the maximum happiness as 6, because in the descending case your deductions was only 4, but here your deductions is 3, 4, 5, 6. So if we compare this last child, you collected 4 happiness because there was 0 deductions, but in this case you collected only 1 happiness because there were 3 deductions. And if you see the first child, you got happiness 0, and the deduction, because the deductions was only 1. In this case you got happiness 1 but deductions is 0. This works. Greedily picking from the largest one helps because of this part. Note that the happiness value can never become negative. So even though you start picking from here, the maximum deductions this child can get is only 1. But here, if you see, this is the last child to be picked. In this case, you got the maximum deductions as 3. So to avoid this and to maximize our sum, we always start picking from the greatest elements. So to solve this problem, first you have the array, you sort it in the descending, you sort it, and then from the end you start picking the key elements. And when you pick, suppose when you pick this guy, you'll get the happiness as 3. And when you pick the next guy, you'll get the happiness after reducing 1 to -1. And suppose you have more people, then for the next person you'll get the happiness value after decreasing 2, and so on up to k elements. And at any point when you subtract, when you do the reductions, if the value is 0, I mean if the value is negative, then you will only take 0, because the happiness value can never be negative. Now let's quickly code the approach. So first let's take long and reductions as 0. Also n will be the happiness dot length. Now first thing we'll do is sorting the happiness array and start iterating the first key elements from the end to n minus 1, I greater than equal to n minus k. So here in your answer, you'll simply add happiness of I minus the deductions. So initially deductions was 0, but in the further iterations, the deductions keep increasing. The first time you'll get happiness of I minus 0. The next time you'll get happiness of 5 minus 1, then happiness of 5 minus 2, and so on. But at any point, this value can be negative. So in that case, to avoid that, you can use math.max this value, comma 0. So if it's negative, then it will pick 0. And if it's not negative, it will pick the positive value. And at the end, just return answer. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, since we are sorting the happiness array, this is NlogN, and here we are iterating on the first k elements. So this is order of k, and k is always less than or equal to n. So worst case, this can be order of n. Total complexity will be order of log n. Coming to the space complexity, it will be constant because we are not taking any arrays, only a few variables and the iterator. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.